Hello class, welcome to lesson 5.1, which is all about solving inequalities by addition and subtraction. By the end of this lesson, you should be able to solve linear inequalities using addition and subtraction. Okay, so let's look at some vocab terms. Set builder notation is a more concise way of writing a solution set. So what set builder notation looks like is this right here, which I'll teach you how to write that a little bit later on, okay? And then a quick refresher. This symbol right here means less than or fewer than. We have our greater than or more than. At most, no more than, less than, or equal to. And last but not least, we have our at least, no less than, greater than, or equal to. Those are all of our phrases for our inequalities. Those are our 4 types. Okay, so let's practice solving each inequality. Solving inequalities is very similar to solving equations. The only difference, instead of an equal sign, we have an inequality symbol. So if we look at our first one, we have 22 is greater than m minus 8. So I tee it up still, and I want to solve each inequality. That means I need to get the variable by itself. So right now, it's m minus 8 on one side of the equal sign. So instead of minus 8 or subtracting 8, I'm going to add 8 to both sides. So I now have 30 is greater than m. However, I'm going to tell you guys, I prefer that you write your inequalities with the variable on the left-hand side and the number on the right-hand side. So now I just need to look, and it's pointing at m, so that means I need to make it point at m. So m is less than 30. Alright, let's try our next one. Tee it up. I have d minus 14 is greater than or equal to negative 19. So what I'm going to do, I'm going to add 14 to both sides. So I now have d is greater than or equal to negative 19 plus 14 is a negative 5. Okay. Now I've solved both of them, but I want to check my solutions because I want to make sure I am getting these correct. So the first one, I have m is less than 30. So I need to pick a number that's less than 30. So what if I plug in like 20? So if I do 22 is greater than 20, because I'm replacing m with a number less than 30, so I chose 20, minus 8. So that's 22 is greater than 20 minus 8 is 12. Is that true? Yes. So I know that my answer is correct. Another one that I could try for letter B, I have d is greater than or equal to negative 5. So if I want, I can select either negative 5, or I could do negative 4, negative 3. I'm going to do a positive number just for fun. So I'm going to plug in a 1 minus 14 is greater than negative 19. So 1 minus 14 gives me a negative 13. Is that greater than or equal to negative 19? It satisfies the greater than part. So I know that this is correct. Okay, so all of these problems on your test, if you check them, you should know if you got them right or wrong. So go ahead and try this first one on your own, see how you do. Hopefully you ended up with k is less than 14. If not, be sure to ask for some help. Let's look at our second inequality. And we're going to solve it, and then we're going to graph the solution set on a number line. So our first one, we have 9n minus 1 is less than 10n. So if I tee it up, I want to get my variables on the same side. So I'm going to move my 9n over to my 10n. So I have a negative 1 is less than 10n minus 9n is just n. And like I said before, I prefer to write the variable on the left-hand side. So I'm going to do n is greater than negative 1. And if I test that, if I choose a number greater than -1, so let's say I do a +1. So I have 9 times +1 minus 1 is less than 10 times the +1. So I have 9 minus 1, which is 8, is less than 10. Is that true? Yes. So I know that answer works out. And now I want to practice writing it in that set builder notation. So the way you do that, you do a squiggly or curly bracket. You write what variable you're using. You do a vertical line. And then you write your inequality. So this is kind of the proper math grammar for writing the solution for an inequality. Okay? This is the proper way to do it. Sometimes I will ask you to specifically write an answer in set builder notation, and sometimes when I don't specify, you're welcome to write it this other way. But if I ask you set builder notation, I better see this answer somewhere. Now the second part of our question was to be able to graph the solution set on a number line. So I look, n is greater than -1, so I go over to -1. Since I don't have that or equal to, I leave it as an open circle. Remember, whenever it's less than or greater than, it's an open circle. Whenever it's greater than or equal to and less than or equal to, it's a filled in circle on your number line. Okay? Or closed. So let's practice. We have n is greater than -1. So I look at my number line, which numbers are greater than -1? To the right. So I fill that in. Alright, let's look at our second one. We have 5h is less than or equal to 12 plus 4h. So again, if I move, I can move the 4h, and what's with h is less than or equal to 12. Excuse me. And then I can test my answer by choosing a number that's less than 12. So if I choose 10, I have 5 times 10 less than or equal to 12 plus 4 times 10. Oops. So I have 50 is less than or equal to 12 plus 40. So 52. 52 is less than or equal to, or is greater than or equal to 50. Or if I read it from left to right like you're supposed to, 50 is less than or equal to 52. So that checks out. So I know my answer of h is less than or equal to 12 is correct. If I write it in set builder notation, I start with an h, vertical line, h is less than or equal to 12. And you'll see the answers in the book when you correct your assignments are written in set builder notation. Okay, so now to graph this, I need to add a couple of lines. So I'm going to do that. And I have h is less than or equal to. So I know it's going to be a closed circle. This is 12 here. And it's going to go the other way. Okay. So that's what my answers would look like there. Go ahead and solve this first inequality. See how you do. Hopefully you ended up with m is greater than or equal to -4. If not, ask for some help. Try this next one on your own. Hopefully for this one you decided p is less than or equal to -6, and you made sure that the graph is correct as well. If you have any questions there, be sure to ask. Let's look at our last example. We have Peter wants to buy season passes to 2 theme parks. If one season pass costs $54.99 and Peter has $100 to spend on both passes, the second season pass must cost no more than what amount? Okay, so Peter has a total of $100 and he wants to buy a ticket for 2 different theme parks. We know that one of the prices is $54.99, but we don't know how much the other one is. Maybe he hasn't picked out a second place yet. So we want to figure out how much can he spend on that second ticket. So if I ask you to set up an inequality for this, what would that look like? Well, we know that one of the season passes is $54.99. we know he has $100 to spend. So if he has $100 to spend, that means he can either spend the 100 or spend less than the 100, right? So we need to make sure that we have it set equal to or less than that $100. And since we don't know what the other season pass costs, we're going to represent it by using X. So that's how I'd set up the inequality. But then if I actually solve it, I can subtract $54.99 from both sides. I'm left with X has to be less than or equal to 45.01. So that means the second season pass has to be $45.01 or less. Needs to cost $54.01 or less. Okay. Go ahead and try this breakfast problem on your own. See how you do. Hopefully you said the total was $8.45. Alright, it can cost no more than $8.45. If you have any questions on any of these examples, be sure to either reach out to myself or a friend, rewatch part of the video. But I hope you guys are having a great day.